see, touch, and even smell is made of tiny particles called atoms. These atoms are the fundamental building blocks of matter. They are incredibly small, yet they hold the key to understanding the vast universe. From the air we breathe to the stars in the sky, atoms are the common denominator. Imagine a Lego set. Each brick represents an atom. These bricks can be combined in countless ways to build different structures. Similarly, atoms combine to form molecules and compounds. Different combinations of atoms result in unique substances. Chemistry is the study of matter and its properties. It explores how atoms interact with each other. It helps us understand the composition, structure, and changes of matter. Chemistry is essential for understanding the world around us. From cooking to medicine, chemistry plays a vital role. It helps us develop new materials and technologies. The field of chemistry is vast and complex. In the following sections, we will explore the fundamental concepts of chemistry. Atoms, the fundamental units of matter, are composed of even smaller particles: protons, neutrons, and electrons. Protons carry a positive charge, neutrons have no charge, and electrons carry a negative charge. Protons and neutrons reside in the nucleus, the atom's central core. Electrons orbit the nucleus in electron shells, much like planets orbit the sun. The number of protons in an atom's nucleus defines the element. For example, an atom with 1 proton is hydrogen. An atom with 2 protons is helium, and so on. Each element has a unique set of properties. These properties determine how the element behaves in chemical reactions. The number of protons is also known as the atomic number. The atomic number is a crucial identifier for each element. It determines the element's position on the periodic table. The periodic table is a systematic arrangement of all known elements. It organizes elements based on their atomic number and electron configuration. This arrangement reveals patterns and trends in the properties of elements. Isotopes are atoms of the same element with different numbers of neutrons. The periodic table is a powerful tool for chemists. It organizes the elements based on their atomic number and electron configuration. Elements are arranged in rows and columns, revealing periodic trends in their properties. These trends allow chemists to predict the behavior of elements. Valence electrons are the electrons in the outermost shell of an atom. They play a crucial role in chemical reactions. Atoms tend to gain, lose, or share valence electrons to achieve a stable electron configuration. The number of valence electrons determines an element's reactivity. Elements with similar numbers of valence electrons exhibit similar chemical properties. The periodic table provides a framework for understanding the behavior of elements. As new elements are discovered, they are added to the table. It is a testament to the power of scientific inquiry. Atoms interact with each other by forming chemical bonds. These bonds are formed through the sharing or transfer of valence electrons. Two main types of bonds are covalent bonds and ionic bonds. Covalent bonds involve the sharing of electrons between atoms. Ionic bonds involve the transfer of electrons from one atom to another. In covalent bonds, atoms share electrons to achieve a stable electron configuration. This sharing creates a strong attraction between the atoms. Covalent bonds are common in molecules formed by nonmetals. Examples include water, H2O, and methane, CH4. Ionic bonds form when one atom transfers electrons to another atom. This transfer creates ions, charged atoms. The opposite charges attract each other, forming an ionic bond. Ionic bonds are common between metals and nonmetals. Table salt, NaCl, is a classic example. When atoms bond together, they form molecules and compounds. A molecule is formed when 2 or more atoms of the same element bond together. For example, oxygen gas, O2, is a molecule consisting of 2 oxygen atoms. A compound is formed when 2 or more atoms of different elements bond together. Water, H2O, is a compound formed from 2 hydrogen atoms and 1 oxygen atom. Table salt, NaCl, is a compound formed from sodium and chlorine. Compounds have different properties than the individual elements that make them up. The properties of a compound are determined by the types of atoms and how they are bonded together. The chemical formula of a compound represents the types and numbers of atoms in the compound. For example, the chemical formula for water is H2O, indicating 2 hydrogen atoms and 1 oxygen atom. The chemical formula for table salt is NaCl, indicating 1 sodium atom and 1 chlorine atom. The properties of a compound can be vastly different from the properties of its constituent elements. The formation of compounds leads to the diversity of matter we observe. Electronegativity is a measure of an atom's ability to attract electrons in a chemical bond. Atoms with high electronegativity have a strong pull on electrons. Atoms with low electronegativity have a weaker pull. Electronegativity plays a crucial role in determining the type of bond that forms between atoms. When atoms with different electronegativities bond together, they form polar molecules. In a polar molecule, the electrons are not shared equally between the atoms. The atom with higher electronegativity pulls the electrons closer to itself, creating a partial negative charge. The atom with lower electronegativity has a partial positive charge. Water, H2O, is a classic example of a polar molecule. Oxygen is more electronegative than hydrogen. Therefore, oxygen pulls the shared electrons closer to itself, creating a partial negative charge on the oxygen atom and partial positive charges on the hydrogen atoms. This polarity gives water its unique properties. The polarity of water makes it an excellent solvent. Matter exists in three main states: solid, liquid, and gas. The state of matter depends on the arrangement and movement of the atoms or molecules. In a solid, atoms are tightly packed with a fixed shape and volume. In a liquid, atoms are less tightly packed and can flow, taking the shape of their container. In a gas, atoms are widely dispersed and move freely, filling the container. Adding or removing energy changes the state of matter. Heating a solid melts it into a liquid, and further heating vaporizes it into a gas. Cooling a gas condenses it into a liquid, and further cooling freezes it into a solid. These transitions are called phase changes. Intermolecular forces are weak attractions between molecules. They are much weaker than the bonds within molecules. However, they play a significant role in determining the properties of liquids and solids. Van der Waals forces are a type of intermolecular force. These forces arise from temporary fluctuations in electron distribution within molecules. These fluctuations create temporary dipoles, regions of partial positive and negative charge. The temporary dipoles in one molecule can induce dipoles in neighboring molecules, creating weak attractions. Van der Waals forces are responsible for the attraction between non-polar molecules. They are also present in polar molecules, but they are generally weaker than the dipole-dipole interactions between polar molecules. The strength of van der Waals forces increases with the size and shape of molecules. Chemistry is all around us, playing a vital role in our daily lives. From the food we eat to the clothes we wear, chemistry is at work. Soap, for example, is a chemical marvel. It works by disrupting the intermolecular forces between water and grease, allowing us to wash away dirt and grime. Baking soda is another example of chemistry in action. It is a base that reacts with acids, producing carbon dioxide gas. This reaction is used in baking to make cakes and bread rise. Plastics are synthetic polymers, large molecules made up of repeating units. They are versatile materials used in countless applications, from packaging to construction. The properties of plastics can be tailored by changing the chemical structure of the polymers. Medications are another example of chemistry's impact on our lives. Chemistry is essential for understanding the universe. It helps us unravel the mysteries of matter and its transformations. From the formation of stars to the evolution of life, chemistry plays a central role. By studying chemistry, we gain a deeper appreciation for the intricate workings of the cosmos. Chemistry is a constantly evolving field. New discoveries are being made all the time, expanding our understanding of matter and its interactions. These discoveries lead to new technologies and applications, shaping our world in profound ways. Chemistry is a driving force behind innovation. By studying chemistry, we can address some of the most pressing challenges facing our planet. From developing sustainable energy sources to cleaning up pollution, chemistry provides the tools and knowledge we need to create a better future. Chemistry is a powerful tool for positive change,